Hello and welcome back to Troubleshooting Pandas. Today we're going to talk about trouble with time series data. And in this video we're going to talk about fixing messy time series data with DateTimeIndex. Let's dive in and take a look. So what I'm doing here is I've opened a browser, and in this browser I've navigated to our Jupyter Notebook environment and opened up the Chapter 5 notebook. In this video, we're going to talk about trouble with time series data. So time series data is very frequently seen. Some of the applications you might see include financial trading, Internet of Things embedded especially industrial, factory, and vehicle processes. And so getting time series data right is a very crucial step about being a good data scientist. So the first thing we want to do, as usual, is to import pandas as PD, as you can see here in 64, and import numpy as NP. The first thing we want to show is how we can fix messy time series data with a carefully crafted DateTimeIndex. In N60, our first example shows us with PD, pandas, .datesRange, which is a function that creates a DateTimeIndex that ranges through a certain number of periods. The first parameter is initialized as 1st of January 2019, and notes that this is just some of the population's representation of the date. So some people might write it 2019-11, or maybe 2019-01-01, or maybe you're also aware of the fact that there's the difference between month first or dates first date formats. So here you can see that Pandas very nicely picks up on the formatting and automatically formats and parses this dates that you feed it. In the second parameter, that's a named or a keyword argument. We're providing the keyword periods, and we're specifying the periods to be 12. What this means is DateRange is going to generate a range in the DateTimeIndex with 12 periods. The last keyword argument we're putting in is the frequency. H here represents hour, and so we're creating 12 hours of January 1st, 2019 of midnight, and that's exactly what we see here. In DateTimeIndex, we're seeing 12 elements starting from midnight, January 1st, 2019, and lasting 12 periods. You can see that the DateTimeIndex has been indexed with a data type of DateTime64 down to the nanosecond in precision, and the frequency is hourly. In 61, our second example, what we see here is again pandas.dateRange. Again, we're starting the date range at 1st of January 2019, and the periods are at 12. The frequency, however, is daily, and so in the DateTimeIndex, what you can see here is there are 12 days that's generated in this date range. And again, the data type is DateTime64 nanoseconds. However, now the frequency is daily instead of hourly. So I'm going to give you 10 seconds just to take a look at the difference between out 60 and out 61, just so you understand. Great. So in our third example in N65, now we're trying to convert a series into a time series. So how do we do that? It's very simple. The way we do this is we create a normal series, and in the index we feed in a DateTimeIndex, and we know how to create this DateTimeIndex because we've learned how to do it in the first and second example of this video. So here in N65, I created a Pandas series by calling pd.series, and first feed in its values. Its values are 12 random numbers sampled from numpy.random.randn, a random number generator that generates 12 random numbers around and using the normal distribution. The index, we're using DateRange again to create a DateTimeIndex that gets fed into the keyword argument index. And in pd.dateRange, we're creating a date range that is starting from 1st of January 2019 for 12 periods and a frequency of daily. As you can see in the results, we have a time series where the time is on the left-hand side and the index of the series, and the value, i.e. that is the random numbers that's generated from randn, is on the right-hand side. You can also see that we have the time series very neatly starting from 1st of January 2019 and lasting for 12 periods on a daily basis. Now let's look at a different use case. Sometimes we receive a time series and we want to resample or change the frequency of these series. So what you can do is, again, we've created a Pandas series in the first call, and we call this function called ASFREQ, standing for as frequency. In the first parameter, we feed in a string that represents how frequent do we want this new time series to be. And in the second keyword argument, we feed in the weight on how we can fill in the gaps whenever there isn't an established value for that frequency. Here we choose the method pad, which means that we take the previously known value and propagate it forward. So let's compare out67 and out65. So here in out65, each row increments by day. Here, first of all, the frequency was hourly, so it should have incremented by the hour. And you can see that we have now resampled or changed the frequency so that it's incremented by 45 minutes at a time. Let's look at a slightly different use case. If we want to resample a series, we can again create a Pandas series, now this time with 72 numbers, and we're creating it in terms of hours. So as we all know, 72 hours, to convert that to days, is to divide 72 by 24, which is the number of hours in the day. 72 divided by 24 equals 3. So by calling a resample of this hourly time series to a daily frequency, we should see 3 numbers pop up. But within these 3 numbers, which one do we pick from the 24 numbers that is available in a day? This is where an aggregator function comes in. We've talked about aggregator functions from the last video. And so the aggregator function I'm choosing today is mean. And basically what this means is we're taking the average of the 24 values in each day and we're putting it against as the value of that day. We can also create a Pandas representation of a time point by using pd.timestamp as a class constructor. When we do this, we can feed in any date string we want, and Pandas will figure it out. Let's look at something different. How about if we want to read data from the disk with time series information? Again, we're using pandas.util.testing to make dummy data. And here we're using tm.makeTimeDataFrame and creating a dummy data frame, df. In df.t, i.e. the column, we assign the value of df's index, thus creating a value column that has a time element. If we inspect the head of df, i.e. the first 5 rows, we can see what we see in out56. If we simply call a toJSON call, i.e. writing this data frame into a JSON, and read it back in as what we see in in58, we can see that readJSON has not successfully recovered the time data present in the data frame. So how do we recover T? The way we recover T is very simple. Here we reread the data and we use the Pandas function toDateTime to convert the time back to a datetime unit. We also need to specify what's the frequency when we wrote this time series data into the JSON file. In this case, milliseconds. If we inspect the head of this table, we can see that we've successfully parsed it back.